Good morning, sir. Myself Bhargavi, and this is my CAO presentation. My CAA2 presentation is to upload video presentation on arithmetic pipelines in computer architecture and organization. And this is the introduction of arithmetic pipelines. In computer architecture and organization is to discover how modern processor break down complex arithmetic operations into efficient parallel stage to achieve unprecedented computational performance. Here we can see what is pipelining means. Pipelining is a fundamental technique that breaks down instruction or data processing into sequential stages. Each stage performs a specific operation, enabling multiple operations to be processed concurrently, much like an assembly line in a factory. Here are three sequential stages: concurrent processing and improved throughput. First of all, sequential stages. Operations flow through distinct processing phases. In concurrent phases, multiple operations execute simultaneously at different stages. Improved throughput. Overall system efficient and speed dramatically increases. Here, floating point addition pipeline. There are four stages. In first stage, compare exponents. Second stage, align mantisas. And in third stage, add or subtract based on the problem. And fourth stage is to normalize result. In first stage, comparing the exponents which determine the difference between exponents through the subtraction to align operates. And second stage is to shift mantisas based on exponent difference to ensure proper alignment. And third is to perform arithmetic operation on aligned mantisas to combine values. And fourth is to adjust result to maintain proper floating point format and precisions. Here is the example. The problem given is to add two numbers x and y. Here x is 3.0.3214 into 10 power 3 and y is 0.4500 into 10 power 2. Here we can see exponents are different from both x and y. Here first step is to calculate exponent difference. When we calculate both exponent difference, we get 3 minus 2 is equals to 1. And in second stage, aligning mantissa y. Because mantissa y has exponent has smaller than exponent of x. After that, shift right by one position, we can get 0.04500 into 10 power 3. Here we can see both exponents are equal. Third step is to add aligned mantisas. Both add When we add both, we get 0.3664 into 10 power 3. And fourth step is to normalize final result. Here already in proper form. Hardware designed architecture. Here are four register stages: advanced adders, designed parameters, and multiplier design. Registers placed between pipeline stages store intermediate results, enabling smooth data flow and preventing information loss between operations. And in advanced adders, carry save adders and carry look ahead orders significantly speed up multiplication and addition operations by reducing propagation delay. In design parameters, pipeline depth and width directly affected performance gain and hardware complexity. Deeper pipelines increases throughout but require more silicon. Fourth one is multiplier design. Pipeline multipliers break multiplication into partial product generation, followed by cascading addition stages for efficient computation. Here are the benefits and challenges. In benefits, increased throughput through operation overlap, efficient CPU and coprocessor resource utilization, essential for scientific computation and multimedia processing, enable high-speed AI graphics workloads. In challenges, we can see data dependence cause pipelines installs and hazards require sophisticated management techniques, balancing depth versus complexity in critical. increase the design and verification complexity. The real world applications of these arithmetic pipelines are integral to modern computing across diverse domains from supercomputing to everyday customer device. Here, first one is supercomputers, graphics processing, and AI workloads and embedded systems. Arithmetic versus instruction pipelines. We can see the difference between arithmetic pipelines and instruction pipelines. In arithmetic pipelines, operation level scope and instruction level scope are both. In instruction pipeline, we can add multiply stages and fetch, decode, execute stages. The power of arithmetic pipelines, foundation, capability, innovation, and future. And thank you for listening to my presentation, sir.